Hi everyone and welcome to this, my 2023 General Mathematics Written Examination 1 Suggested Solutions for General Maths. I think I've already said that. Anyway, my name's Darren from Maths Guru. Thanks very much for joining me. Hopefully these answers are going to prove useful. If you've done the exam today, awesome. Fingers crossed, all is good and you came out of this very, very happy. I've done pretty much 3/4 of the exam at the moment. I'm like, oh, this has actually been quite fair. If you're using this for later revision, then awesome. Hopefully everything here will be correct. Now, if I do make any mistakes, and there's always one question that trips me up, I'll put an errata down below in the description. All right. But obviously, you know, if you can do me a massive favor of subscribing to my YouTube channel, it really does mean the world to me. If you've watched any of my previous videos, really, who watches maths videos? Very, very few people. But by doing it, you literally make my day. I had 40 subscribers sign up yesterday. I nearly had a heart attack. Literally, no one watches my videos. Yeah, maths videos, now people want to watch animation and people cooking and stuff. So that click is really, really awesome for me. Right, so should we get going? I think so too. Right, so by the way, I don't work for VCAA. I don't have access to their solutions. I don't have any of that type of stuff. This is just my view on what I think the answers should be. Hopefully I don't go through it too quickly. I know that many of you out there are like desperate to get the answers. I know they'll release on Reddit and what have you, but here we go. These are the worked solutions. The dot plot below shows the times in seconds of 40 runners. Okie dokie, we've got 40 runners in the qualifying heat of that 800-meter club. Yep. The median time, okay, I want the one in the middle. They told me there were 40 data items, so if I split that in the middle, I'd have 20 on one side and 20 on the other. So I'm probably looking for the 20th and the 21st, partway through the 20th and the 21st dot. Now, obviously, it's important to count in the right way, so I'm going to start at the bottom and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So there we go. They are basically my 20th and 21st dot. It fits on 136. So I'm going to say B there is what I would believe is the correct answer. If you see me keep looking off screen, it's just because I've got my answers that I've already done. The shape of the distribution is best described as. I never remember this. Literally, what I had to do was fire up my summary book again. And basically, right, well, if it's going this way, yeah, if it's going this way and then it has a long tail that way, it's positively skewed. We don't know if it's an actual outlier, so it's a possible outlier. And for that situation, I said it was positively skewed with one or more possible outliers. So I went for A for that one there. Let's just check. Yep, still went for A. Right, Gemma's favorite online word puzzle allows her 12 attempts to guess a mystery word. Her number of attempts for the last 5 days is displayed in the table below. So what I saw here was I've got a number of data items. Yep, on day 6. So we're going to add a day 6. I don't know what day 6 is, so I'm just going to put down X here. Let's call it a value. How many attempts can she make so that the mean number of attempts for these 6 days is exactly 8? Now, I'm sure there's lots of ways of doing it, but the way I did it was go, well, if I do this number plus 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 this number, that's the sum of all the numbers, and divide by 6. So what I did was I said, well, 8 plus 11 plus 5 plus 6 plus 9 plus x divided by 6. That's the mean of all of those numbers. Well, they've told me it wants to be exactly 8. Now, when I put that into my calculator and solve for x came out to be 9, and in which case E was 9. Now, again, there may have been other ways of doing this. I don't know, but I know that lots of people would have said, well, 6 times 8 is 48. All right, so that's basically, we've got 6 numbers. We want them to be an average of 8, so they've all got to add up to 48 and find that. Same. The time spent by visitors in a museum is approximately normally distributed with a mean of 82 minutes and a standard deviation of 11. Now, whenever I do these questions, I always draw a bell curve. Always draw a bell curve. Now, I know different textbooks do it in different ways, but there we go. So there's my bell curve. Very, very happy. Mean of 82. Now, believe it or not, because I've made so many mistakes in this question, I don't think there's anything wrong with putting 82 into my calculator and then doing plus 11. Right, to get me my next sets of numbers. So there's 93, 104. Hold on, you can't see the calculator. 93, 104, and 115. And again, if I now do 82 and then do minus 11 3 times, I get 71. I get 60 and 49. All right, so there we go. So what do we want now? We want, using the 68, 95, 99.7% rule, the number of these visitors are expected to be between 60 and 104. Now, I tend to color all of this in. 60 and 104 is basically, well, I thought that was quite nice because that there is 68% of the data, and between either side of those two lines is 95%. So I'm looking for 95% of how many people I've got. Well, they told me in the question there were 2380. So 2380. And again, put down to my calculator, 95 divided by 100. Times that by, what did I have here? 2380 gives me 2261, and D was the answer I thought. I keep saying the correct answer. If I say the correct answer, it's what I think the correct answer is. The height of a group of year 8 students has a mean of that, a standard deviation that, and a z-score of that. Okay, nice and easy. So z-score is equal to my actual minus my mean divided by my standard deviation. So they had a z-score of minus 0.85. Actual I'm going to call x. My mean I knew was 163.56. Divide that by my standard deviation of 8.14. And again, to be honest with you, I just put this on my calculator and I said solve, if you will, minus 0.85 equals, let's do that, x minus 163.56 divided by 8.14. And solve for the missing value gave me that. Now, obviously, my calculator at the moment is in a stupid think mode. I'll change that in a moment. 156.6. Oh, there you go. That's an answer that I've got there. So I'm fairly confident that B there would be the correct answer. Now, I'm just going to change my calculator settings. 7, there we go, 2, float. And let's make this approximate. Click on OK. We are done. All right. So far, I think that was really, really fair. Then we get to logs, and anyone who I teach logs to, I'm saying the first thing you do is you change these log numbers along the bottom into actual numbers. Now, this question didn't quite work that way, because what you've got is a histogram below displays the number of prices in dollars, or the distribution of prices in dollars of the cars for sale in a used car yard. The histogram has a logarithmic based in scale. 6 of the cars in the yard have the following prices. How many of the 6 car prices listed above are in the modal class? Well, the modal means the most common. Here is my modal class here, and it goes between 3.5 and 4, at least a log 10. So to turn those into actual numbers, I do 10 to the power of 3.5 and 10 to the power of 4. So put that into my calculator, 10 to the power of x, I've got that button here. He says, trying to click it on the thing, 10 to the power of 3.5 gives me 3162.28. And then 10 to the power of 4, let's hit that button there, to the power of 4 gives me 10,000. Probably should have already known that one. There we go. So there's my 10,000. What have we got here? So we're looking for cars that go between that. Well, nope. That's too big. This one seems to work. That one seems to work. And that one seems to work. And that one's too low. So I'm going to go for C3 as my correct answer. Yay! All right, again, logs. It's interesting how every single year they just slightly change how they ask those questions. This was an awesome question, very clever about residuals. A teacher analysed the class marks of 15 students who sat 2 tests. The test 1 mark and test 2 mark, all whole number values, are shown in the scatter plot below. The least squares line has been fitted to the data. The equation of the least squares line is closest to. Now again, in this situation, what I do is I tell my guys choose 2 points on or near the line. So let's actually choose those 2 points there, okay? And what am I going to do? I can do a linear regression with just those 2 points. So I'm going to do control and doc. Let's add a list and spreadsheet. Let's put this as test 1. Oops, where am I? Test 1, test 2. And what are my 2 values? So 16, 18. So all I've done here is read off the coordinate value of here. It's 16 and 18. And then this one here is 36 and 49. 36 and 49. 36 and 49. Got my 2 points. What am I going to do now? I'm going to go control doc. And again, there's lots of ways of doing this. I like pretty graphs. Along the bottom, we've got test 1. Up the side, we've got test 2. Yep, that seems to be sloping in the right direction. So what do I do now? Menu, analyze, regression, linear a plus bx. And beautifully out comes the answer of minus 6.8. and plus 1.55, right? Minus 6.83 plus 1.55. I think the only one that it can be is actually A there. None of the others tend to work. Yeah, they're all close, but not quite there, all right? Oh, minus 6.8. Yes. And again, the one that I just wanted to check there was that one there because it got markedly close and I was a little bit worried about that one. Okay. The least squares line shows the predicted test 2 mark for each student based on their test 1 mark. Okay, the number of students whose actual test 2 mark was within 2 marks of that predicted by the line is. So what they're really saying is find the number of dots that have a gap no more than 2 places away. And again, you had to go through and test each of those. Well, the ones I did were the ones that sat on or very near the line. So those 3 there, automatically, they're absolutely. And then I went through each dot and went, well, you know, and again, the trick here was 2 marks, yes, was actually just 1 square. So that was a no. That was, close, but it said it had to be, if I just check the wording, the number of students marked was within 2 marks. It can't be including 2 marks. So that would have been a bit of a trick question. This one here is obviously within 2 marks, that one there. And there was another one, which is that one there. I think when you do the rest of them and look for how many sort of squares they are away from the line, they're way above 2. So I got 1, 2, 3, 4, 5. And so in that situation, I thought 5 was the correct answer. So C, yes. The least squares line can be used to model the birth rate population in the country from the average daily energy. So there's my energy, and there's my birth rate. It said when a least squares line is it's found out for a country with an average daily food intake of 8.53, the birth rate will be 32.2. So that's 8.53 and 32.2. And we got another one here, which is 14.9. And this one is only 9.9. So that's 9.9 there. So again, the slope of this least squares line is closest to, again, this was a skill that they'd already tested. So I went back here. I changed my titles here to, what did I change it to? Energy, E-N-E-R-G-E-Y, and I changed it to BR. And again, I put my 2 values in that they gave me, which was 8.53 and 32.2. Move this down, and then I got 14.9 and 9.9, I think it was. And then I went, oh, here we go. We go back, and hold on, my data disappeared off there. And I was like, why did that change? Well, obviously, because I've now got to change my things here. So what did I have? Energy and birth rate. And I was like, yay. And that seemed to fit really well. And so what did I have here? I had y is equal to 62.06. Well, I'm not interested in that. I'm interested in my gradient. And again, the trick to this question was that plus and minus there, which meant minus. So it's minus 3.5. So I'm going to go with B as my answer there. Now, that whole skill of being able to put 2 points into, you know, a calculator and finding the gradient is just invaluable. Now, a study of year 10 students showed that there is a negative association. I think the trick word here was association, which must talk about increasing and decreasing. It's got something about that between the, between the scores of a topic test and the time spent on social media. So I'm going to do time on social media, and I'm going to do my scores here. There's a negative association, which would suggest it's going to go like that. And the coefficient of determination is 0.72. I think that was going to try and trick people because people are going to think that was the value of R. Right, from this information, it can be concluded that when we work, I'm going to work from E upwards. When we work from E upwards, it says here, a decreased time spent on social media is associated with a decreased topic test score. So a decreased time on social media is a decreased time. Well, that's blatantly wrong, so that can't be right. D. Too much time spent on social media causes a reduction in topic test performance. No, there are lots of different things. And again, there was nothing there that said increase or decrease for both of them. So that's a no, just because of the trick of the language. An increased time spent on social media is associated with an increased topic test. Well, no, that's blatantly not true, because as we increase this, we're not increasing it, we're decreasing. So that's a no. Less time spent on social media causes an increase in topic test. Again, that's not an association. Yes, it might well be that you think that's the case, but it isn't. It's got to talk about an increased or decreased time, not less time. There are other factors that might affect test performance. A is the only answer that we have left. Okay, and again, that question I looked at for a few minutes and I went, right. Right, use the following information for questions 11 and 12. The table below shows the height in meters and the age in years for 11 plantation trees. A scatter plot displaying the data is shown. Okay, a reciprocal transformation is applied to age and can be used to linearize the data. Oh, guess what? I'm going to go back and fire up my calculator, and I'm going to put all that data in because I know that it's going to ask me to do it. So we've got age, we've got height. Sorry about that. Let's just pull that down. And then we're going to go height again, if you would be so kind. And then what I'm going to do is put the data in 10, 8, 13, 9, 11, 14, 6, 4, 12, 7, and 5. Right, again, did I want 11 data items? Yes, I've got 11 data items. Go up. And let's overwrite these with 9.58. And I'm always checking when I put this information in that the value I'm saying and the value I'm putting in is correct. That few seconds extra can save you from losing 1 or 2 pointlessly lost marks. 7.8 and 4. All right, good. So that all matches up. What am I going to do now? Well, I always want to make sure that my graph looks like it's supposed to. I want to make sure that it looks like, before I do any transformation, that one there. So again, so what I do now is go over here. I go, oh my goodness, that's not right, because I now want age and I want height. And there we go. Does that look right? It does. I'm not bothered about this linear regression in the moment because I'm actually going to change it by going back. So now what I'm going to do is I'm going to do the reciprocal of age. So I do rec age, I do a title, I'm going to do equals 1 divided by my var of age. Hit enter, and yep, it'll overwrite whatever data I've got in there. And there we go. So now go back here, change my age to rec age, and what happens? There we go. We get a nice, almost straight line, and I've got my linear regression line. So we've got to now try and fit it to the right one there. So again, many cases in these exams, they'll try and trick you by writing height and age the wrong way, or some of these they'll miss 1 on age, but here they did it. And so you were just finding 13.04. It's got to be positive and minus 40.2. And again, I know it's really hard because I can't circle it because it's a different screen, but that plus minus means it's minus. So I'm looking for 13.04 minus 40.02, which I think gives me D as my correct answer for that one there. Okay, carrying on. So again, if I'm honest with you, and I don't mean this to make any of you out there feel bad, but I think this was a relatively fair paper so far. Okay, there are some questions coming up that I'm like, but anyway, the scatter plot can be used to linearize using a log base 10 transform applied to the variable age. The equation of the least squares line is this. Using this equation, the age in years of a tree with a height of, so they're doing it backwards. They're giving me an equation and they're telling me the height. So what I'm going to do now is I'm going to 8.52 equals minus 3.8 plus 12.6 times log 10 of age. That's what I'm trying to solve, and realistically speaking, there we go. That was the trick to the question. So again, I typed into my calculator, solve 8.52. He says 8.52 equals, what did I say? Minus 3.8 plus 12.6 times, let's use the log 10 button on my calculator, 10, call it x rather than age, comma x, and out comes 9.501. Is that one of my answers? It is. So again, in that situation, I'm going to go for D. So again, that's just knowing how to use the solve function on your calculator. The following graph shows a selection of winning times in seconds for the women's 800-meter track event from a various athletics event worldwide. The graph shows one winning time for each calendar year from 2000 to 2022. Now, the first time I looked at this, I went, oh, great, time series. Question 12. The time series is smoothed, using 7 median smoothing. The smooth value for the winning time in 2006 is. So what I do is I'm going to find my 2006 dot. It's here. I want 7 dots, where that one's in the middle. So it means I've got to have 3 on the left, and I've got to have 3 on the right. Now what I do, and this is really hard to do on here, guys, because I can't tell you, is I'm going to take a ruler, and I'm effectively going to move that ruler up and down and see where my middle dot is vertically, because it wants the median winning time. So moving this up, I've got 1, 2 dots there. There's my 3rd dot, and there's my 4th dot. Now again, because I want 7 median smoothing, I'm looking for that 4th dot up. 1, 2, 3, 4, and I've now got to read off where that is. Now again, it's going up in 0.2, so knowing the scale gives me 116.8. So in which case, I'm going to say it's C is my correct answer. I'm just going to turn the page of my solutions I did earlier. He said, ouch, that was loud. 116.8. Awesome. It went on. The median winning time in seconds for all of the calendar years. Okay, so we want all of the calendar years. So very similar. All I needed to do was firstly count how many dots there were in total. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there are 23 dots. If I want the median dot, I'm going to add 1 and divide by 2. So that tells me the median dot is going to be the 12th one from the bottom. So again, very much like I did just then. Let's draw a straight line, he says. And let's move it up. Can I move it up? Yep. So I want the 12th dot. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, there's one over 9, 10, 11, and 12. So there we go. That would mean that this dot here, and I would read that off as 117.2, which would give me B for there as well. So again, knowing how to do that whole sliding thing with your ruler, it has been really important in this one here. Oh, question 15. The number of visitors to a public library each day for 10 consecutive days was recorded. The results are shown in the table. The 8 mean smooth number of visitors with centering for day 6. Well, the first thing I tend to do with day 6 is I do a line there because I'm going to do the left of day 6. And I want 8 data items. So I want 4 here and 4 here. Now, when I do that on my calculator and do 317 plus 313 plus 335 plus 322 plus 335 plus 322 plus 338 plus 302, because we want the mean, we've got to add all those values together and divide by how many there are. So that gives me on that side 323, he says, writing in highlighter again. So 323. And what I'm going to do is delete all of that, and I'm now going to center on the other side. So again, I want 4 on the left of that line, and I want 4 on the right. Now, a shortcut to being able to do this is copy all that down. I'm going to add on 349. I'm going to scroll to the left. And I'm going to take away those values there. So that's the sum divided by 8 to give me the mean. Gives me 300. Oh my goodness, why do I do that every single time? 327. So 327 minus 323 gives me 4. I'll try that one again. I'm trying to add them together. What am I doing? 327 plus 323. Divide that by 2 because I want the average of those. Give me 325. And so I'm going to say C there is the answer that I suggest was correct. Oh, question number 16. The number of visitors each month to a zoo is seasonal. Okay, correct. The number of visitors in January for seasonality, the actual number of visitors to the nearest percentage increased by 35. The seasonal index for that month is closest to. There are a number of ways of doing it, but I have to say we teach where I am. 100 minus the seasonal index divided by 100 will give me the percentage change for seasonality. Now, because it's increased by 35, we do 35. I'm basically going to put that into my calculator and go solve, comma, well, let's make that X, all right, or SI for a moment. And again, if I put that into my calculator, he says clicking on the image, I get solve 100 divided by, let's call it X, minus 100 equals 35, comma X. And there we go, get 0.740. Is that one of my answers? I should Coco. So I think for that one, D would be my correct answer. All right, so there's my data done. Not necessarily anything particularly disgusting. That last question was very unique. And again, it always fascinates me. Now, have you subscribed to my YouTube channel? I keep forgetting to ask that. If you haven't, if you could do so, it would be massive. Again, it means so much to me. No one watches these videos. No one watches mathsguru.com. If you went out at the moment and told all of your teachers about mathsguru.com and the fact I create these videos and your schools actually use my resource, I would be the happiest maths teacher on the planet because I'm helping as many kids as I can. If you can subscribe, tell your teachers, I'd be really, really grateful. All right, so he says, sounding terribly needy. Let's go on. A sequence of numbers is generated by the recurrence relation shown below. T0 equals 5. To get to the next term, I just times by minus 1, the one before. Okie dokie. So let's say we got T0 equals 5. To get to the next one, I'm just going to times by minus 1, which is going to give me minus 5. To get to my next one, I'm going to times by minus 1, which is going to give me 5. And what did it want? It wanted the value of T2 is 5. So I'm going to go D is my correct answer. Are we happy with that? I hope so. Sorry about the noise. I'm turning pages. Terrible recording etiquette, but hopefully you'll cope. Next one. Gus purchases a coffee machine for $15,000 and depreciates its value using a unit cost method. The rate of depreciation is 4 cents per cup of coffee made. Okay. A recurrence relation that models the year-to-year value G of N in dollars is the machine. Now, when I did this question, I looked at it for like 5 minutes going, you what? It's the year-to-year value. So N there stands for years. A rule for G of N. a rule. So we're going from the recurrence relation to a rule. For the value of the machine after n years, well, the machine is depreciating by $1,314 per year. So that's what I'm going to multiply by n. And so in which case, because we know that it's got to be V0 minus my depreciation times n, I'm going to go for C as my correct answer there, because basically it's just going to depreciate by 1314 every single year. Again, a bit of a red herring with that one, because I kept looking at this 0.04 and say, well, why did they give that to me? Ha ha! Then we moved on to question 19. The number of cups made by the machine per year is, okay, and I've seen this type of question on the previous VCAA exam. So it's $1,314 divided by 0.04, because it's 4 cents per cup. So if I now go 1314 divided by 0.04, I get 32,850. So I'm going to go E as my answer there. For taxation purposes, Audrey depreciates the value of her $3,000 computer over a 4-year period. At the end of the 4 years, the value of the computer is $600. Yay! If Audrey uses the flat rate depreciation. Now, flat rate depreciation means it goes down by the same amount every single year. So it started at $3,000. It ended up at $600. So it lost $2,400. Okay, but that was over 4 years, which means it lost $600 per year. Now, knowing that information means that I can say, well, if it's losing $600 per year, that's 600 divided by the 3,000, and I'm going to times it by 100, he says. And that's going to give me, let's just work that out, 600 divided by 3,123, and times it by 100 gives me 20%. So I'm going to go C as my correct answer there. If Audrey uses reducing balance depreciation, the depreciation rate per annum is closest to, well, okay, reducing balance depreciation gives me that V of M is equal to R to the power of what? N times V0. Well, we know what V0 is, so I'm just going to write this around slightly different. That's going to be 3,000. We know that V of N is 600. And I'm going to times that by R to the power of 4. So let's put that into my calculator and solve for R. So what do we got here? So we're going to solve. Did I say solve there? Yep. 600 equals 3,123 times R to the power of 4. And we're going to do comma R, if you'd be so kind. And we get two values. We get a plus value and a negative value. Well, I'm more interested in the positive value. So that's going to be 0.66. Now again, let's take that 0.66. I'm going to times that by 100. So it's 66% of what it started with, which means it's actually gone down by 33%. All right. So in that situation, my depreciation is 33%. And again, if you wanted to, you could go back and check that. Timmy took out a reducing balance loan of $500,000 with interest calculated monthly. The balance of the loan in dollars after n months can be modeled by the recurrence relation. A final repayment that will fully repay the loan to the nearest cent is, okay, as far as I'm concerned, this was a financial solver question. Again, there may be other ways of doing it. I quite like financial solver. So let's actually have a look what information I've got here. I've got my principal value. We've got a loan of 500,000, 500, 1, 2, 3. Got a payment of minus 2611.65. He's going to repay the loan. Okay, so future value is 0. What have we got here? Interest is calculated monthly, so that's there. And I got a bit of an issue. I don't know N. I don't know N. In fact, I don't know I. But what I soon came to realize was, well, actually, I do know I, because they told me here that that's my rate of interest. All I've got to turn that is back to a nominal rate of interest, not a monthly rate of interest. So I know if I take 1.00325, subtract 1 from it, times that by 100 and times it by my compounding periods, that will get me back to my actual rate of interest. And again, if that doesn't make sense, there is a formula on Maths Guru that I use to show people. So if you're new and you're not doing this in 2023, then watch videos on Maths Guru. It's absolutely free to sign up. There are a lot in there are free for you to use. So hopefully. So what I'm going to do now is go 1.00325 minus 1 times 100 times 12. Gives me 3.9%. So that's my annual interest rate of 3.9%. So fingers crossed. Now, if I go menu, finance, financial solver, lucky me, it's deleted it all. Oh, how frustrating is that? Right. So let's go again. And I don't know. I'm going to try and find it. I is 3.5. Principal value is 500, 1, 2, 3. Payment was minus 2611.65, and that's 12 and 12. So if I do that there we go. I get 300.000. Now, what that means is I've got 300 payments. So now I'm going to make that 300 because I don't want that decimal, because I know that my future value is going to be a smidge out. Now, what does that mean? That minus 2.465? It means that at that final payment, if I make 300 payments, I'm still going to owe $2.46. So the best thing to do is do the 2611.65 and add on that $2.47. And when I do that, and hopefully you guys will trust me, I get 2614.12. So D there would be my correct answer. All right, there was actually quite a lot of working out in that one. Question 23. Tavi took out a loan of $20,000 with interest compounding quarterly. Okay, so you're compounding quarterly. She makes quarterly repayments of $653.66. The graph below represents the balance in dollars of Tavi's loan at the end of each quarter of the first year of the loan. Okay. The effective interest rate, right? We want effective interest rate. It's financial solver, and remember your financial solver gives you a nominal rate of interest. So I'm going to go back here. What I'm going to do is I'm going to use my principal value here and my final value here. Okay, so I've got N as 4 because there's been 4 payments. My interest rate, do I know what my interest rate is? No, because I'm going to try and find it. My principal value is 2123. She's taken out a loan. My payments were minus, what did they say? 653.65. My future value, I'm just going to read off of payment 4, which is 18084.39. Payments per year is 4. Compounds per year is 4. So when I get my interest rate, something's not right there. You're all screaming at me because I didn't do my minus value there. And I love the fact the calculator tells you. So if I go to my interest rate there, I get 3.624. So my PA is 3.624. So now I'm going to go to my effective one. So EFF, there's a menu function for that. 3.624, comma 4. Hit enter gives me 3.67. So there we go. So I'm going to go for D as my answer there as 3.67. Let me just check that I actually did that earlier. Yeah, 3.67. Right, the next part of this question I thought was pretty tricky. The following recurrence relation models the value Pn of a perpetuity. Now we've got to remember it's a perpetuity, you just live off the interest. And the interest is effectively this payment here of D. All right, the value of R can be found by calculating. Now, if I had numbers in here, what I'd be telling my kids to do, or you to do, in fact, is you always do that divided by P0. So my interest rate, yeah, not as a percentage, as a decimal multiplier, would be the value of D divided by A. But because interest is getting added on, what do we then have to do? Well, that's when you add the 1 plus R on 100 business. Well, we're not going to do 1 plus R on 100. I'm just going to add 1 to that. So add 1. Now, again, if you look there, there's no value there that can do that. And this is where it comes back down to your fractions. And what I then said, well, if I want a common denominator of A, I'm now going to change that to D on A plus A on A. And then I can combine that to become D plus A on A. And we don't have that option, but we do have A plus D on A. And so B, I think, was the correct answer. Interesting question. And there we go. That was the finance over and done with. Again, if I'm honest with you, relatively okay. Now, if you've just joined me for Matrices or you fast forwarded, thank you very much. Great to see you. If you can, please subscribe to my YouTube channel. I got 40 subscribers yesterday. Literally had a heart attack. I run around my apartment when I get 3, much less 40. Can you imagine what I did? Whoa, I upgraded from McDonald's to KFC. No, I didn't. If you can subscribe, it means the world. So many people out there create videos that are food-based and sort of animation-based and sort of stupidity-based. Who watches maths videos? And you're only really watching this because I'm doing exam solutions. I'm so sorry, very judgy. But if you can subscribe, it means the world. And if you can tell your teachers out there that you're using Maths Guru and that they should really be doing this instead of things like Edrolo and what have you, I'd be really, really stoked, right? I think my resource is pretty awesome. What am I talking about? Right. Question 25. The daily maximum temperature at a regional town for 2 weeks is displayed in the table below. The information can be represented by matrix M shown below. Element M21 indicates that. All right, so we're on element M21. Row, column. Second row. So here's my second row. First column. There we go. So I'm looking for this value here. What does it stand for? 29 degrees on Monday of week 2. So the temperature was 29 degrees on Monday in week 2. I'm going to go A. Yay! Right, matrix P is a permutation matrix and matrix Q is a column matrix. Cool. When Q is multiplied by P, which three letters change position? Now this comes down to your understanding of, do you know what a leading diagonal does? Well, the leading diagonal for a permutation matrix is really important because when you have a 1 on that leading diagonal, it means that those things do not change place. So in that situation, the first element and the fifth element won't change place, which means that E, A, and M will change place. And I think it says which three letters do change position. B is my correct answer. Right, the following transition matrix models the movement. Let's turn my calculator off for a moment. Now, this is pretty much where I stopped with my solutions. Let's see how far we go. Let's put that on the floor. It's no use to me anymore. The following transition matrix T models the movements of a species of bird around 3 different locations, M, N, and O, from day 1 to the next. Which one of the following statements best represents what will occur in the long term? Ooh. Right, so what I'm going to do first is I'm actually going to put this into my calculator. And so I'm going to go T becomes equal to, now again, a lot of people do store, but let's not worry about that for the moment. So what have I got here? Number of rows is a 3 by 3, has to be square. So I've got 1 on 3, 0, 0.9. Not very nicely put fractions in this, but anyway, 1 on 3, 1 and 0.1, and 1 on 3, 0, 0, hit enter. So there we go. That's all my decimals now. Which one of the following statements best represents what will occur in the long term? I'm now going to do T to the power of 50 and hit enter. All right, and what I get here is my percentages of what is going to take place. And so basically the problem here is that means 0, 0, 0. These values along here mean that there is basically going to be 0% of anyone being in there, or 0% of what I start with is going to be there. So there's going to be no birds at M. All right, which of the following statements best represents what will occur in the long term? So no birds will remain at location M. No birds will remain at location N. That's not true. Basically, they're all going to end up, because basically that 1, and 1, and if I raise that to a power of 100, let's see what happens if I raise that to a power of 100. Let's do that there. There we go. So again, that is basically 0 because it's e to the minus 14. So no birds will remain at location M. So that's a possibility. No birds will remain at location N. No, they're all going to end up at N. All of the birds will end up at location M. Nope. All of the birds will end up at location O. Nope. An equal number of birds will be at all 3 locations. No, well, in which case it's A. And raising your transition matrix to a high power, but looking at the actual percentages, can actually make life a lot easier. And hopefully that question there was easy for you guys to do. Question 29. 4 table tennis teams played in a round robin tournament. Each team played each other team once, and there were no draws. The overall ranking of each team at the end of the tournament based on number of wins is shown in the table below. First, second, third, and fourth. A dominance matrix can display the results of each game where 1 in the matrix shows that the team named in the row defeated the team named in that column. The dominance matrix for this tournament could be, okay, based on the overall ranking of each team at the end of the tournament. 4 table tennis teams played in a round robin. Each team played each other team once, and there were no draws. The overall ranking of each team at the end of the tournament based on the number of wins is shown in the table below. A dominance matrix that can the dominance matrix for this tournament could be. So S has got 3 wins. So right, what I'm going to do here is just look at that. S has got 3 wins, T has got 2, U has got 1, V has got none. So in that situation here, we'd have S, T, U, and V. Nope, that doesn't seem to work. All right, so let's have a look at the next one. S has got 2 wins, T has got none, U has got 3 and 2. So that's probably not going to work because we don't have joint seconds in any of this. So let's have a look at the next one. We've got 1, 1, 2, and 2. That doesn't seem particularly nice at the moment. 1, 0, 3, and 1. I got some, and 2. Oh, that might be the one. So let's actually see who comes first. So that would be U, V, S and T, U, V, S and T. Oh, that's looking likely. And in which case, let's just check the other one here. We got 1, 0, 4, and 2. So in that situation, we'd have U, V, S, and T. Oh, that's interesting. U, V, S, and T. So why have I got 2 different ones here? So let's just check that one there. 1, 2, 3, 1, 2, 0, 1. U, V, S and T. U, V, S and T. The dominance matrix for this tournament could be. And now we had a bit of a problem, and I looked at this and I was like, what do I do now? And I reached out and I phoned a friend, believe it or not. So thank you very much to my friend who I've just had a quick chat with. And I was like, hold on a moment, they give the same. And they went, look at E again. And I was like, why would I look at E again? And what do I notice? I've got a 1 in a leading diagonal. What does that mean? It means that they played themselves. And that doesn't really make a lot of sense, does it? So in which case, the only correct answer has to be D. I'll be honest with you, I was like, do I have to square it? I'm not really sure. Would I square it? Again, something so innocuous as that little line really, really annoys me. All right, matrix K is a 3.2 matrix. The elements of K are determined by that matrix K is. Now, again, if you're a ClassPad user, I am so sorry, but if you are a TI in SPA, you know that you've got a function that can do this for you. So I'm going to go menu, matrix and vector, create, and I'm going to do construct matrix. Now, when I do that, although apparently I didn't because I didn't have my thing in there properly, so matrix create. Construct matrix. We know that for this thing here, we put I minus j, and you square it in there. You do comma I, comma j, comma I, comma j, comma, and the size of the matrix you want 3 by 2. Hit enter, and out comes your answer there. So 0, 1, 1, 0, 4, 1, 0, 1, 1, 0, 4, 1 gives me E as your correct answer. And to be honest with you, I'd be really surprised at the number of teachers who don't know that that function exists. Okay, so if you've been watching my Maths Guru videos, yay! And talking about Maths Guru, can you subscribe to my YouTube channel, please, if you haven't already done so? And are you aware I have merchandise? How bizarre is that? Look, Maths Guru mugs with a funny quote on the back. Yes, I don't know who I'm talking to. Available on mathsguru.com. And this hoodies, any color you like. Under the side, we've got myriad of Marion bows. I'm very thirsty, so bear with me. Okie dokie. So, yuck, I hate water. Gross. Yeah, if you can subscribe to my YouTube channel, it'd be massive. Thank you so very much. Very few people watch maths videos, and I would really like to get more and more people to use my videos. How many of the following statements are true? All square matrices have an inverse. No. Okay, the reason being there is if I had a square matrix of 2, 4, 1, and 8, that certainly wouldn't have an inverse. Why? Because if you multiply the opposite corners, you get 8, and 8, take that away, you can get 0. There isn't an inverse, so that's definitely not true. Statement true. The inverse of a matrix could be the same as the transpose of a matrix. Now, I'm 98% sure that that is true for something else. I'm going to check that one in a moment. If the determinant of a matrix is equal to 0, then the inverse does not exist. That's absolutely true. It is possible to take the inverse of an identity matrix. Ooh, there's an interesting question. Let's do that. I'm going to put an identity matrix in here, and I'm going to go... I'm fairly sure you can. Let's just put an easy one, 2 by 2 in. To prove, I've got 1, 0, 0, 1. Let's raise that to the power of -1. And there we go. Yep, we can absolutely take the inverse of an identity matrix. I'm sure there are people screaming out going, yes, of course you can. Right, I'm just going to check. I'll be back in a second. Okay, so coming back to that, what did it say? The inverse of a matrix could be the same as the transpose of the matrix. Looking at permutation matrix, see, p to the -1 equals pt. So it says how many following statements are true? The inverse of a matrix could be the same as the transpose of a matrix. I'm going to say yes, that's true for a specific case. It's not always the case, but the inverse of a matrix could be the same as the transpose. So I'm going to go for D as my correct answer there. Right, moving on. What do we got now? A species of bird has a lifespan of 3 years. The females in the species do not reproduce in their first year, but produce an average of 4 female offspring in their second year and 3 in their third year. Oh, here we go. Leslie matrix L below is used to model the female population distribution of species bird. The element in the second row, first column, states that on average 20% of this population will be NAP. So if you remember, these are my birth rates going along here, and these are my death rates. I don't like that. Yes. So basically 20% of the people will actually, no, hold on a moment. Birth rates go that way. Survival rates. Sorry, they're my survival rates. They're not my death rates, they're my survival rates. So 20% of the people in that age will survive. So be female. Nope. Never reproduce, nope. Survive into their second year. Oh, sorry, 20% of the population will be female. Never reproduce, no. Survive into their second year. I'm going to go with that one for the moment. Let's just read the rest. Produce offspring in their first year, no. Live for the entire lifespan of 3 years, no. All right, so in which case, an understanding there of Leslie matrices, I'm going to go for C there as my correct answer. For one particular week in a school year, students at Phyllis Island Primary School can spend their lunch break at the playground, basketball courts, oval, or the library. Students stay at the same location for the entire lunch break. Ooh. The transition diagram below shows the proportion of students who change from one location to the next. Could you have chosen any more complicated transition diagram? Anyway, the transition diagram is incomplete. There's a surprise. On the Monday, 150 students spend their lunch break at the playground. Oh my goodness, here we go. So I've got the playground. What did they say? 150 students. 50 students at the basketball court, baseball. 220 spend it at the oval. 220 at the oval. And 40 students spend it in the library. Library is 40. Okay. Of the students expected to spend their lunch break on the oval on the Wednesday, the percentage of these students who also spent their lunch break on the oval on Tuesday is closest to. Right, here we go. So the first thing I actually did there was go, right, okay, let's try and make my transition matrix work. And when I did that, there's a certain amount of information missing. And we got from P to P, from B to B, from O to O, and from L to L. So everything on my leading diagonal. But what we do know is that my columns all add to 1. So I now know that I can probably fill those in. So 0.3, 0.7, 0.8, that's going to be 0.2. 4, 5, 6, 7, that's going to be 0.3. 3, 6, 7, that's going to be 0.3, 4, 5, 6, 7, that's going to be 0.3. So there's my transition matrix. I have my initial state matrix there. So what was that? That was on Monday. So what am I now going to do? Well, it says of the students expected to spend their lunch break on the oval on the Wednesday, the percentage of these students who also spent their lunch break on the oval on Tuesday is closest to. Right, let's see what happens now. So what I've done now is put the information into my transition matrix and my S0. So just looking at my calculator, just to save some time for this video, there is my T for my transition matrix, and there's my S0. So let's see where we go with this one there. So I'm now going to do S0, put that one there, and I'm going to do T times my answer. So this is Tuesday, and that is Wednesday. All right, so what do we want? Of the students expected to spend the lunch break on the oval on Wednesday. So oval is going to be my third value. There are 127 students on the oval on Wednesday. So of the students who are expected to spend the percentage of these students who spent their lunch break on the oval on Tuesday is closest to. All right, so what do we got here? So from the oval to the oval, well, we've got of these students, 127%. So if I go back now, my oval, I had 140 students on Tuesday. So if I look at my data here, I had 140 students on the oval on Tuesday. Yes? So of the students expected to spend their lunch break in the oval on Wednesday, the percentage of these students who spent their lunch break on the oval on Tuesday is, so how many of those 140 were made up 127. So we know from oval to oval is 30%. So if I do 0.3 times 140, so I'm going to do 0.3 times 140, tells me that 42 of those kids would have done that. Times that by 107, so 42 divided by 127. I'm going to times that by 100, gives me 33%, which I think is C as the answer. Okay, so, yep, I'm going to go see with my correct answer there. Well, that was the end of matrices. That last question was like, oh, and here we go. We now go on to networks and decision matrices or decision mathematics. If you can subscribe, that would be great to my YouTube channel. I'm so needy, I know. Or buy merchandise. Have I mentioned my merchandise? I do merchandise. I know, mass hoodies and stuff. Anyway, if you can subscribe to my YouTube channel, it's great. Nobody watches maths videos. I keep saying this over and over again. I got 40 subscribers yesterday, nearly had a heart attack. Like, seriously, yeah? My dog thought I was nuts. I was running around. I literally phoned my mum in the United Kingdom and said, Mum, I'm going viral. And she went, you got a virus? And I went, no, let's not go there, Mum. It's a bit embarrassing, really. She doesn't know what YouTube is. Maybe she should sign up. I get one extra subscriber. Anyway, if you can subscribe, it would be greatly appreciated. And turn off notifications if you don't ever want to hear from me again. Like, seriously, if you don't want to hear from me again, that's fine. I get that. All right, here we go. Let's make a start on this work. Networks and decision mathematics. Consider the following graph. How many of the following five statements is true? The graph is a tree. Yes, it's a tree. I hate these questions with a passion. So let's say the graph is a tree. Yes, that's true. The graph is connected. Yes. The graph contains a path. Yes, because I can go from one to another. The graph contains a cycle. No, it doesn't. It doesn't create a cycle because there's no loop. The sum of the degrees on the vertices is 8. So that's a degree of 1. 2, 2, 2, and 1. 1, 2, 3, 4, 5, 6, 7, 8. That will give me yes. So we'll go with yes to that one there. So I'm going to go with 4 as the correct answer there. So for D. Okie dokie. And question 34, storming to the end of this, he says, no, a bipartite graph is typically used to display which one of the following? The allocation of tasks on a construction site? Nope. The path used to visit 5 different construction sites? No. The total distance traveled between 2 construction sites? No. The critical path? No. The minimum length of cable required to connect 6 construction sites? The allocation of tasks on a construction site? I may have said no. Looking at that one again, it's the only one that it can be. All right, he says, so, you know, the allocation of tasks on a construction site, that works. The path used to visit 5 different construction sites? No. The total distance traveled between 2? No. The critical path of activities to be completed? Nope. And the minimum length of cable? No. Look, as far as I'm concerned, the only one there can be A. All right. Here we go. Next one. Consider the weighted graph shown below. The weight of the minimum spanning tree. All right, the minimum spanning tree. Let's work out. So I tend to highlight all of the low values. So 7. Yep. We're going to have 8. Yep. We're going to have 9. Yep. And we're going to have 10. So adding those together is going to give me, let's do it on my calculator because I don't want to make a stupid mistake. 8 plus 10 plus 9 plus 6 plus 7 is going to give me 40. So I'm going to go with C for that answer there. All right, now moving on to question 36. 4 employees, why is this not moving? A, B, C, and D are each assigned a different duty by the manager. The time taken for each employee to complete duties 1, 2, 3, and 4 in minutes is shown in the table below. The manager allocates the duties so as to minimize the total time taken to complete the 4 duties. The minimum total time taken to complete the 4 duties in minutes is... Now, what I've got here is I've got a really handy program on my calculator, which I basically downloaded from the interweb. And there's obviously a lot of these out there to be able to help you do these type of things. So Hungarian algorithm is one of those that just takes way too long to do. So what I'm going to do is I'm actually going to fire this up and test it out. So the first thing I'm going to do is I have to put my matrix in. So I'm going to do C becomes equal to, and then I'm going to do what? This, and I've got a 1, 2, 3, 4 by 4. So 4 by 4. And then what you do is put the numbers 8, 7, 7, 8, 10, 8, 10, and 9. 8, 9, 7, and 10. 7, 7, 8, and 9. Put that in there, and off we go. Then what I do apparently is I go to here, and I go menu, matrix, user defined, and type in the matrix. Now I called it C, so I'm going to hit enter, and there we go. There's my C. 8, 7, 7, 8, 10, 8, 10, 9, 8, 9, 7, 10, 7, 7, 8, and 9. Apparently when I hit enter, it actually does the Hungarian algorithm for me. So there we go. That is the task that should be allocated to each person. It doesn't actually ask that. It wants to know what is the minimum sum or the minimum total time taken to complete the 4 duties in minutes is, in which case that says 30. So I'm going to circle B for 30. Can you imagine those of you out there who have had to do that by hand? I am so sorry. That would be awful. All right. But again, sometimes using the technology makes life a little bit easier for me. The adjacency matrix below represents a planar graph with 5 vertices. The number of faces on this planar graph is, right, I'm going to turn my calculator off and I'm actually going to draw it. So I'm going to do J, K, L, M, and N. So it's J, K, L, M, and N. And J is, so what's J is connected to K. J is connected to M. And J is connected to N. So all I've done here is I've just looked down there. Okay, so J not connected to J. J is connected to K. All right, K is connected to, so let's just do that one now. So I'm going to highlight that one there. All right, so K is connected to J. We've already got that one. There is 2 connections from K to L. So there's 2 connections from K to L. 1 connection from K to M. and one for connection from K to N. So I'm going to draw that around here like so. They don't have to be straight lines. Let's go L. L is connected to J, no. L is not connected to J, nope. Two connections between L and K, yes. No connection from L to L. L and M have got one connection, so there's L and M has got one connection, and L and N has one connection. So L and N has one connection. Right, here we go. Next one. We've got M. Oh, he says, let's do a highlighter. M, I am recording. Yep, M and J is 1. So M to J is 1, yep. M to K is 1, yep. M to L is 1, yep. M to N. I haven't got an M to N yet, so there's my M to N. And what do we got here? Last one. Should already have all of this. N to J. N to J, yep. N to K. N to K, yep. N to L. N to L, yeah, N to M, and N to N. So there we go. The leading diagonals, there's no loops. So let's just check how many faces I've got now, and we'll do that in a different color. So the faces are anything that's enclosed. 1, 2, 3, 4, 5, 6, and include the outside one, which would be 7. Let's just check that. 1, 2, 3, 4, 5, 6, and 7. I'm going to go with B as my correct answer there, as 7. Okay, question number 13.8. Oh, here we go. A particular building project has 10 activities that must be completed. These activities and their immediate predecessors are shown in the diagram below. A directed graph that could represent this project is... Yay, why do you keep making us draw these things now? Right, so here we go. So A and B. Let's just do that first. There's A and B. All right, C comes off of A. D comes off of A, so there's C and D at the moment. E comes off of B. F is D and E. So F is D and E. All right, so I'm going to now connect E onto here for the moment, because F can only start when E and D is done there. Guarantee there's going to be a dummy in this question. G can only happen when C and F are finished. All right, so... there was my C. There was my G. H can only start when F is finished. Right, so there we go. So F can only start... let's go back to that one again. So I had C coming off of here, didn't I? C came off of A. Yep, right. So G can only start when C and F are finished. So G can only start when C and F is finished. Right, so G can only start with C and F. H can start when F is finished, so there's H. I can only start when D and E are finished, so I can come off of there. And J can only start when H and I are done, so I. So G can only start when C and F, so G has to go into I as well. No, it doesn't. G has to go into the end of I. Right, there we go. So we've got G. So what do we want? How's that going to look? A, B. Ooh, so this is going to take some time while I get my head around this one, so bear with me. A and B, C and D come off of A, B and E, yep, go into C and F join together. Nope. So I've got C. Let's do this one. A, B, C and D come off of there. So there's my C and D coming off of A. F comes off of D and E. F comes off of D and E. There is a dummy there between C and the start of G. So I've got my F here. Okay, so looking at this again, and I've just paused for a moment, I am fairly sure that the dummy goes from the end of F to the beginning of G. And the only one that happens to the end of F, the beginning of G, is this one here. Okay, is D. So I'm actually just going to scroll up a little bit and try and work out, sorry, I know you can't really see this, and I'm very sorry about that, but maybe I can move this down a moment. Let me just see what happens here. Oh, it's gone off the screen. It will allow me to move this down. Yep, so let's move that up a bit so we've got D. Right, A and B are coming off the start, so yes, I agree with that one. E is coming off of B, yes, so A and B is coming off the start, E is coming off of B. C and D are coming off of A, C and D are coming off of A, yep. Okay, F and I are coming off of D, F and I are coming off of D, yep. There is a dummy from the end of F to the beginning of G, end of F to the beginning of G. G connects into the end of J, that is, I think. I connects up with D and E. J starts with H and I. I've drawn that diagram wrong. Hold on a moment. Let's just backtrack that one for a moment. So I comes off D and E. J can only start when H and I are finished. There you go. Sorry. J can only start when H and I are finished. So that's actually J there. Oops. Sorry, guys. Bear with me. That's got to be J. Okay. So let's go back to that one. There's a G going in and there's a J. So there's my G and there's my J. All right. So I am 98% sure that D is going to be my correct answer there. Okay. So again, if you disagree, by all means, let me know. Fingers crossed I'm on the right track here. So questions 39 and question number 40. And then we're at the end of the thing. The network below shows one-way paths between entrance A and exit H of a children's maze. The vertices represent the intersections of one-way paths. The number on each end is the maximum number of children who are allowed to travel on. The cuts on the network are used to consider the possible flow of children through the maze, the capacity of the minimum cut or maximum flow. Now, again, I really like these questions. Hopefully, it's going to work with this one here, because what I do is I choose a path. I look for the smallest value on there and I subtract it. So that's going to be 0, that's going to be 5, that's going to be 2, all right? Because I've used 10 capacity there, right? So that's that path done. What path am I going to use next? Well, why don't we try this one here, okay? So I've got 12 and 2, which means that 2 are going to go off of there. And that means I've only got 10 going there. So that's that one there. What have we got next? So I'm going to try this one here. All right, what have I got here? 8, 7, and 8. So 7, that's going to be 0. That's going to be 1, and that's going to be 1. So I said there was 7 there. All right, where are we going next? Let's delete those. What I got next? Maybe this way, this way, this way, and this way. Okay, 10, 4, 4, and 8. So again, I've got 4. So I'm going to write 4 here. So that's going to become 6. That's going to become 0. That's going to become 0. And that's going to become, what did I say, 6. And obviously I'm always looking for making sure that I can get water through. And believe it or not, I think that's me done now, because I can't get anything through there. I can't get anything through here. Okay, I can't get anything through there. That's a 0. Have I got zeros anywhere else? Yeah, I can't get anything through there. Have I got zeros anywhere else? No. So if I'm just checking my pass through, if I go that way, well, I can't go backwards down there, so that's not going to work. If I go here, I can't go backwards through there. I can go down here, but I can't go backwards through there. So I think my minimum cut or maximum flow will be the sum of all those numbers, which is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I'm going to go for B as my correct answer there. Okay, 23. And let's just see where that would go. So that would go here, 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 and there. So 12 and 4. 12 and 4, it gives me 16, 17, 18, 19, 20, 21, 22, 23. So I'm fairly sure that's going to be my correct answer. Okay, so now moving on to question 40. Now, you may, eagle-eyed people, be suddenly, hold on a moment, the colours of that's changed, the numbers have changed. Yes, it did absolutely change. I'm going to get rid of that +6 for a moment. The reason being is I actually went back and I wanted to check with my diagram that I actually did, because sometimes doing the orders in different ways. So sometimes Let's do this one here and that one there. Sometimes if you go along here and then, sorry, here, you can get different answers. I didn't get different answers. I still got 7, 8, 20, 23. So I got B for that one. What I did end up was question 40 worked slightly nicer for me. So one path in the maze is to be changed. Which one of the 5 changes would lead to the largest increase in flow from the entrance to the exit? So increasing the capacity of flow along CE to 12. So what I'm going to do is zoom in for a moment, he says, and I'm going to highlight CE where you are, and I'm going to increase that to 12. Now what that actually does is, initially it was 4, increase it to 12 gives me 8 capacity. So that's got an extra 8. Now, if I now flow along here, that's got 6 there, I've got 8 there, and I've got 1 there and 7 there. So actually 6, what did I say, 8, 1 and 7. That's only going to give me an increase of 1. So by doing that there is going to give me an increase of 1. I can't get fluid anywhere else down there. So actually that's going to give me an increase of 1. All right, so now I'm going to rub that out and start again. So for information, increasing the capacity of FH to 14. So I'm going to highlight FH, where are you there, to 14. Now what that means is I've got an additional 4 capacity. Why? Because it was 10. I got an additional 4 capacity. So that's 7 now becomes 8, 9, 10, 11. So I'm going to write an 11 up here for the moment. So let's see whether that's going to help. I've got a 10, a 15. Nope, I can't go that way. Nothing can go along there. I've got 6. Nothing can go along there. I've got a 6. And nothing can go along there. So basically, what you tend to find out then is that nothing can go along FH. It doesn't matter what I do to FH. It's not going to make any difference whatsoever. So I decided that had basically no impact whatsoever. All right, and this is +1. Next one that came up was increase the capacity GH to 16. So let's do GH to 16. There we go. So it was 12. It means now I've got an additional 4 that I can flow through. Well, that's nice because I've got 10, 15 and 4. So that means I've got an impact of +4 there. Can I get anything else? Does that open up any other way to get there? Well, I've got nothing going through there. 6, nap. Right, so basically when I do my other routes, I can't go through there either. So that's no use. So that was a mass, that had a capacity of 4, maximum capacity of 4. So that's +4. Reversing the direction along CF. Oh, okay, then. So here is my CF. That means that that 6 is now in play. Well, let's see what we can do. We've got 6 here. We've got 6 here, and we've got 7 there. Oh, very exciting. That means I can get a +6 by going that way. Is there anything else flowing through CF that could also now have an impact? Nope. There's nothing else flowing into it other than just A to C. So basically, that means that that one there has an impact of +6, and you think to yourself, well, surely that's it. Right, reverse the direction of flow along GF. So GF is here. That means that 10 is in play. All right, what can we do here? Well, if we look at this now, we've got 10, 15, 10, and 7. That means that I'd have an impact of 7. And I'm fairly sure there's no other way to get any fluid through that, just to work it out. So no, I can't go through there. There's no way in. So I think that's got an impact of 7. He says writing +7 there. And so I am fairly sure that E is what I would choose if I was doing the exam, and I'm done. I'm finished this exam. Thank you very much for watching. Hopefully it's been useful. If you disagree with any of the answers, by all means, let me know below. Fingers crossed you have smashed this and you have seen all the examples. I'm going to turn the aircon off in my studio because I'm freezing cold. Please subscribe to my YouTube channel if you can. It really does mean the world to me. Thank you very much. And I'm going to try and do the same thing for Monday's exam for those of you who are sitting it in 2023. Otherwise, fingers crossed you can find the paper 2 on my YouTube channel. Take care, guys. Good luck for the rest. See you soon.